Hello kids, welcome to Learner's Planet. Kids, this is our fourth session for factors and multiples. In our previous sessions, we have discussed about prime numbers, composite numbers, factors, multiples, and we have already discussed divisibility rules of some numbers. Okay, in this session, we'll be discussing some more concepts. So let's begin this session. Kids, let's discuss a new term that is co-prime numbers. We have already discussed about prime numbers. Now what were prime numbers? Prime numbers are the numbers which are having exactly two factors, that is number 1 and the number itself. Say 2, 3, 5, 7, all of these are prime numbers since they don't have any other factor except 1 and the number itself. Okay. Now let's learn this term co-prime numbers. Here, two numbers not necessarily prime are co-prime if they have only one as common factor. Okay. Here are some examples: 1 2, 1 3, 3 4, 3 10, 3 8, 5 6, 7 8, etc. These numbers are called as relatively prime numbers. Kids, what are co-prime numbers? This is a definition I have mentioned over here. Just take 2-3 more examples. Suppose I have a pair of numbers 2 and 5. Okay. 2 and 5, both of them are prime numbers. Also, they are co-prime since they don't have any other common factor except 1. Okay, what are the factors of 2? It's 1 and 2. Just write over here. And what are the factors of 5? It is 1 and 5. So you can see there is only one common factor, that is 1. Okay, so 2 and 5 are co-prime numbers, or we can say they are relatively prime numbers. Now let's take 1 or 2 more examples. Suppose I have numbers 8 and 9. Now I list down the factors of 8. They are 1, 2, 4 and 8. And now I write down the factors of 9. So it's 1, 3 and 9. Now we can see that there is only one common factor, that is 1 is factor of 8 also and 1 is factor of 9 also. No other number is factor of 8 and 9 which is common. Okay, so it's only one common factor, that is 1. That's why 8 and 9 are co-prime numbers, or we can say relatively prime numbers. Okay. Kids, it is not necessary that two numbers are co-prime only if they are prime. In this case, 8 and 9, individually they are not prime numbers, but as a pair they are co-prime numbers. And why they are co-prime numbers? They have only one common factor, that is number 1. Let's take one more example. Suppose I have numbers 14 and 15. Now I just write down the factors of 14. It's 1, 2, 7 and 14. Okay, now I just write down the factors of 15. It's 1, 3, 5 and 15. Further we can see that there is only one common factor between these two, that is number 1. So further 14 and 15 also have only one common factor, that is number 1. So even 14 and 15 are co-prime numbers. So whenever two numbers are having only one as a common factor, they are known to be co-prime numbers, or we can say relatively prime numbers. Now we can draw one more conclusion over here, that the continuous number, that means two consecutive number, are always co-prime. Okay, isn't it? See, we can see 7, 8, 5, 6, 2, 3, 3, 4. All of these are coprime numbers. Okay. So whenever you see a pair of consecutive numbers, you just can say that these are coprime numbers. Okay. Now let's understand one more term. Kids, before we learn new term, we should keep these 2 points in our mind. These points are very important. Two distinct prime numbers are always coprime, but converse need not to be true. Two distinct prime numbers are always coprime. That means if two numbers are prime, then their pair will be a set of coprime numbers. We can say 2, 3, we can say 2, 5, we can say 5, 7, 11, 13. Okay, so all of these are prime numbers. That means the pair of them will be coprime. Okay, and similarly consecutive numbers are always coprime numbers, as we have already taken examples 7, 8, 9, 10, 11, 12, 13, 14. Okay, it is not necessary that both the numbers in this set is prime, but since they are consecutive, they won't have any other factor as common except number 1. Okay, so these are also coprime numbers. In this case also 9 is not prime number, 10 is not prime number, but it is a set of coprime numbers. Okay, so I hope you are clear with the definition of coprime numbers. Now let's learn what are twin prime numbers. Now let's see what is twin prime numbers. If the difference between two prime numbers is 2, then the numbers are called twin prime numbers. Okay. For example, 3, 5, 5, 7, 11, 13, 17, 19, 29, 31. Kids, in this case, both the numbers should be prime. Okay, and if the difference between these two prime numbers is 2, then we call them twin prime numbers. Here 3, 5, both of them are prime numbers, and the difference between these two prime numbers is 2. So 3 and 5 is known as a set of twin prime numbers. Okay, or we can say even 5 and 7, the difference between these two prime numbers is 2. So these are called twin prime numbers. Okay. Similarly 11, 13, 17, 19, 29, 31. In all of these cases, both the numbers are prime numbers and the difference between them is 2. Okay. So I hope you are clear with the definition of coprime numbers and twin prime numbers. So do not get confused. Now we'll be taking some questions and problems. Kids, now it is time to solve some problems. We have already discussed how to find whether a number is prime or composite. Now let's take some practical problems. I have already given a chart over here in which the counting from 1 to 100 is written. Now the very first question is, what is the smallest prime number? Kids, you know that which is the smallest prime number? The series of prime number begins with number 2. Okay, and what about 1? 1 is neither prime nor composite. So 1 is the only number which is neither prime nor composite, and the series of prime numbers begins with 2. So the smallest prime number is number 2. Okay, so it's number 2. Okay, now let's take the next question. Now the second question, how many prime numbers are there from 1 to 100? Kids, we have already done an activity in our previous session. So you can revise that session. I'm just writing down the answer over here. There are total 25 prime numbers from 1 to 100. And even I'm marking the prime numbers over here is 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, 31, 37, 41, 43, 47, 53, 59, 61, 67, 71, 73, 79, 83, 89, and 97. So we can count how many prime numbers are there. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, and 25 prime numbers are there from 1 to 100. Okay, and you can revise the activity, that how we are calculating whether this number is prime number or not. Okay, now let's take the next question. Now the next question is, which is the smallest composite number? Kids, let's see over here. 1 is neither prime nor composite. 2 is the first prime number. Okay, 3 is the prime number. So the smallest composite number is number 4. Okay, 1 is neither prime nor composite, and 2 and 3 both of them are prime numbers, and the smallest composite number is number 4. Okay, let's take the next question. Now give an example of even prime number. Kids, in the entire series of prime number, there is only one even prime number, that is number 2. Okay, so there is only one example of even prime number, that is number 2. Okay, all other prime numbers are odd numbers. You should always be clear about it, that there is only single even prime number, that is number 2 in the series of prime numbers. All the remaining prime numbers are odd primes. Now the next question is, how many even prime numbers are there? In the previous question we have already discussed that in the series of prime numbers there is only one prime number which is even, and that is number 2. Except 2, all the prime numbers are odd numbers. Okay, so how many even prime numbers are there? It's 1 only. And what it is? It is number 2. Okay. Now the next question is, how many one-digit prime numbers are there? Kids, whenever we have to find out prime numbers, the very first step is we just cross all the multiples of 2, 3, 5 and 7. Okay, and leave 1 as it is. So I'm just not including 1. I'm not taking this 1. Let's cancel it. Now cross the multiple of 2. It's 4, 6, 8 and 10. Okay, now cross the multiple of 3. Cross or circle whatever. So it's 6 is already there. Now it's 9. Then cross or circle the multiple of 5. We have already done that. Now cross the multiple of 7. It's not there. So now we are left with the prime numbers. So we are left with 2, 3, 5 and 7 which are having single digit, and these are prime numbers. So how many one digit prime numbers are there? These are 2, 3, 5, 7, and in all there are 4 one digit prime numbers. Okay. Now the next question is, what is the addition of first 4 prime numbers? Now which is the first prime number? It's number 2, then it's number 3, then it is number 5, and it is number 7. Okay, so we can find their addition. It is 7 plus 5, 12, 12 plus 3, 15, 16 and 17. So what is the addition of first 4 prime numbers? It is 17. And if you are asked what is the addition of first 4 odd prime numbers, then you have to skip 2. Then you have to take the numbers 3 plus 5 plus 7 plus 11. And their addition will be 5 and 3, 8, 8 plus 7, 15, 15 plus 11, 26. Okay, so you should be clear about the question. If we are asked what is the addition of first 4 prime numbers, then 2 will be counted. If we are asked what is the addition of first 4 odd prime numbers, then 2 will not be counted. Okay, let's take the next question. Now the next question, which is the smallest 2-digit composite number? Kids, we have already circled the prime numbers. Let's do it once again. So when I'm not counting, 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number. In the first line, except 1, 2, 3, 5 and 7, all of the numbers are composite numbers. Now, which is the smallest 2-digit composite number? It's number 10, isn't it? Okay, it is a composite number and it is the smallest 2-digit number. That's why number 10 is smallest 2-digit composite number. Okay. Now in this question, which is the smallest 2-digit prime number? Okay, now let's circle once again. In the second line, we have to cross the numbers which are multiple of 2, 3, 5 or 7. So I'm just crossing the multiples of 2. Okay, now I'm crossing the multiples of 3. 15, 18 is already there. Now I'm crossing the multiples of 5. So 15 and 20, both of them are already there. Now I'm crossing the multiples of 7. So 14 is already there. Now we are left in the second line. We are left with prime numbers. This is 11, 13, 17 and 19. All of them are prime numbers. Now the smallest 2-digit prime number is number 11. Okay. In the previous question, we discussed about the smallest 2-digit composite number and it was number 10. Now the very next number after 10 is number 11, which is a prime number. So the smallest 2-digit prime number is number 11. Okay, I hope you are clear. Now in this question, which is the biggest 2-digit prime number? Okay, kids, in the last line we have to see, that means from 91 to 100, we have to see which is the biggest number and which is that is prime also. Now we just have to repeat the process. Just cancel out all the multiples of 2, 3, 5 and 7. Okay. So I'm cancelling the multiple of 2. So it's 92, 94, 96, 98 and 100. Now I'm circling the multiples of 3. So it's 93. 96 is already there. Then 99. Now I'm cancelling or circling the multiples of 5. So 95 is there. Okay. Now I'm taking the multiples of 7. So it's 91. Now we are left with how many numbers? There is single number, that is number 97. Since it is not multiple of either 2, 3, 5 or 7, so it's a prime number. And since it is the highest number which is having 2 digits also, so it's a highest 2 digit, or we can say biggest 2 digit prime number. So it's number 97. Okay. I hope you are clear. Here in this question, write 5 examples of coprime numbers. Now what are coprime numbers? The numbers which are having the common factor only as 1. Okay. And we have already discussed about the 2 types of coprime numbers. The one is, we can say, consecutive numbers. They are always coprime. So we can take maybe 20, 21, 2, 3, 5, 6, 7, 8. Okay. So all of these are coprime numbers. And similarly, we can make the pairs of prime numbers. The pair of prime numbers are also coprime number. Say 5, 7, 11, 13. Okay. Maybe 17, 19. Okay. So it's a very easy question. I hope you are clear. Now, in this question, we have to write 5 examples of twin prime numbers. Now, what are twin prime numbers? Let's recap the definition of twin prime numbers. The two prime numbers which are having the difference between them as 2 are known as twin prime numbers. Say, for example, 3 and 5. 3 and 5, both of them are prime numbers, and the difference between them is 2. So it's a set of twin prime numbers. Okay. Similarly, we can say 5, 7, 11, 13, 17, 19, 41, 43. Okay. There are many more examples of twin prime numbers, but in this question, since we are asked about 5 examples, I have mentioned these 5 examples over here. So once again, the individual number should be prime and the difference between them should be 2. Then they make a set of twin prime numbers. Okay. Now in this question, we have to write the prime numbers. In the very first question, we have to write all the prime numbers between 14 and 35. So in exam, what you would do is, you just write down the counting from 14 to 35 as I am doing over here. So it's 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33, 34 and 35. This is the first step. Then what you have to do, you have to circle or cross the multiples of 2, 3, 5 and 7. Okay. This is very easy. If you are clear that you have to circle or cross the multiples of 2, 3, 5 and 7. Okay, let's do it. First of all, I circle all the multiples of 2. So it's 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 and 34. Now in the second step, I will circle all the multiples of 3. So it's 15, 18 is already there. 21, 24, 27, then 33. Okay, now I will circle all the multiples of 5. So it's 25 and 35. Now I will circle all the multiples of 7. So it's no multiple of 7 is there. Now we are left with 4 numbers, that is 17, 19. I'm sorry, 5 numbers are there: 17, 19, 23, 29 and 31. All these 5 numbers are prime numbers. So it's very easy. And how would you do this in your exam? That I have discussed over here. So prime numbers between 14 and 35 are 17, 19, 23, 29 and 31. Okay. So whenever you are asked about the writing down of prime numbers or composite numbers between two numbers or two given numbers, then you just write down the counting from the first number to the last number. Then just circle or cross the multiples of 2, 3, 5 and 7, and the remaining numbers will be prime numbers. Okay. And if you are asked about the composite numbers, then all the numbers which are circled are composite number, and all the numbers which are not circled are prime numbers. Okay. So let's do one more example. Now let's take one more example. Let's find out the prime numbers between 51 and 72. So what is the first step? Just write down the counting. It's 51, 52, 53, 54, 55, 56, 57, 58, 59, 60, 61, 62, 63, 64, 65, 66, 67, 68, 69, 70, 71 and 72. Now what is the next step? Circle the multiples of 2, 3, 5 and 7. Okay, let's do it. So first of all, let's circle the multiples of 2. It's 52, 54, 56, 58, 60, 62, 64, 66, 68, 70 and 72. Now let's circle the multiples of 3. The first multiple of 3 over here is 51. Now every third number will be multiple of 3. So it's 1, 2, 3. It's already circled. Then 1, 2, 3. It's 57. It's multiple of 3. Then further the third number, that is 60, which is already circled. Then the further third number, it is 63. It is also multiple of 3. Then 1, 2, 3. 66, it is also multiple of 3. Then 1, 2, 3. 69, which is also multiple of 3. Now let's circle the multiples of 5. So the first multiple of 5 is 55. Then 60. Then 65. Every fifth number will be multiple of 5. Then after 65, it will be 70. Now let's find out the multiples of 7. So the first multiple is 56, which is already circled. Then every seventh number will be multiple of 7. So it's 63 and then 70, which is already circled. Now we are left with how many numbers? 1, 2, 3, 4, 5. That is 53, 59, 61, 67 and 71. All these 5 numbers are prime numbers. and the numbers which are circled are composite numbers. So if you are asked about composite numbers, write the circled number, and if you are asked about the prime numbers, write the numbers which are not circled. Gradually, once you are clear about the concept of prime numbers and composite number, you don't have to write all these numbers. Okay, so just practice and you will be able to write all the prime numbers and composite numbers. Kids will be taking more such problems in our next session. Till then, do revise this session and the previous sessions of factors and multiples. Bye bye.